All right, well today we're going to look at section 5.4, how to divide some decimals. We're going to go right into it and see how to do examples such as this. Now, if you were faced with this type of problem, 370.4 divided by 8, if you didn't have the decimal there, would you be able to solve the problem? Would you be able to do the division?
Yeah.
How would you set it up?
8 out.
8 outside of what?
370.
And you'd have that little box thing. Yeah, the division symbol. Well, we're going to set that up the same exact way. So we'll have 370.4 inside, 8 on the outside. We can do division exactly the same way with decimals as we did with whole numbers. The only thing you have to remember is that if you have a decimal in your number inside of our division symbol, that also needs to be translated to the top of our problem or the quotient. So if we have a decimal here, the first thing we're going to do is move that right up there. Then we'll do our division just like normal. How would we do our division? Let's refresh our memory on that. What would we check first?
8 divided by 37.
Good. You check the 3, right? But that's not going to happen.
4.
So into 37, you get 4. Good. Then what?
Subtract 32 from 37.
How are you getting 32?
8 times 4.
So we multiply. Yeah, then we subtract, and we're going to get 5. The way you know if you're doing the math correctly is if you have a number smaller than what you're dividing by. That's the way you know, without being negative. Now what are we going to do?
Drop down to 0.
And we repeat the process. It's called the algorithm. The algorithm is just a process that you do to get an answer. And we check how many times 8 goes into 50. That is
6.
Good. So 6 goes up here.
40.
We'd subtract, we'll get 2. Again, we'll bring down that 4. Goes in how many times?
3.
We're going to double check to make sure we don't have a remainder. Our answer is, that's it, 46.3. So, dividing decimals works just the same thing as whole numbers as long as you remember that that decimal place needs to be carried up into the quotient. Okay. How about we do a couple more together, and we'll keep on going after that. Okay, so I've already set up for you. What's the first thing you're going to do, please?
Line it. Put the decimal in there.
Okay, that's important. We got to do that. Make sure we're putting that decimal right up there, right above where it is now. Hey, by the way, what number goes there?
0.
0.
So if we check 32 into 8, we can put a 0 up there if it doesn't go in. That's fine. How about 32 into 83? How much is that going to be?
Twice.
5.
Twice. You could estimate, right? Use 30 if you'd like to. 30, 60, too much. So 60, that's 2 times. And then we'll multiply, we'll get 64. Of course, we subtract, how much do we get there?
16.
All right. No?
19.
Yeah, it looks like 19 to me. We'll bring down that 2, and then we check again. How many times does 32 go into 192? Estimate with the 30 if you'd like.
6.
Bless you. 30, 60, 90, 120, 150, probably 6 times. So 6 times, that's 12. We'll carry our 1. We get 19. If I subtract, I get 0. So my answer again is 0.26 or 0.26. By the way, does it still work if I have negative numbers?
Yes.
Why don't you try a couple of these on your own? Try this one for me. You know what? Actually, let's do them together just to make sure we get this down. I'll give you some to try on your own in just a little bit. First thing, when we're setting up division, even though this one's smaller and positive, we're going to put this on the outside of our division symbol, and inside we put our 15.89. Real quick question, is our answer going to be positive or negative, do you think?
Negative.
Why negative?
Because the
Negative and a positive.
So the division rule for signs says that I don't really have to worry about the signs here as long as I know my answer is going to be negative. So I put that negative up there first. That'll help us out a little bit. What's the first thing we're going to do?
put the decimal on top.
Okay, so I gotta do that. Make sure our decimal's in the quotient somewhere. That's important. We don't want to lose track of that thing. Then we're going to start dividing. What's the first number we're going to get?
1.
14 goes into 15 how many times?
One.
We'll multiply, we'll get 14, we'll subtract, we'll bring down the 8
One.
once. We multiply, we get 14, we subtract, we get 4, we bring down the 9. Are you still okay so far?
Yes.
How many times does 14 go into 49?
3.
3 times.
3 times. But wait a second.
I think it's 4.
4 times?
No, that'd be 50.
No, 3.
You can have a remainder.
No. Isn't it if it goes over you add a 0?
Wait a second, let's keep something straight here. We have going into this number 3 times, yes?
Yes.
We multiply, we get 12.
1,
We multiply, we add, we get...
42.
42.
But wait a second, when I subtract, I get 7.
All the remainder of 7.
No, don't you add a
But
0?
wait, we have a decimal place.
Bring the 0 down?
What we can do with
Round it.
decimals, we can put zeros at the end of numbers and it doesn't change it, right?
Mhm.
Let's add some zeros on this thing. If we put a 0 at the end of this problem,
You bring it down?
we can now bring a 0 down and continue our problem for as long as it takes if necessary. I'll erase this carryover. I don't want to confuse that with anything.
So in decimals, you never have a remainder?
In decimals, you never have a remainder. You'll just continue going until you find an answer or until you get a repetition. We'll see some of those in just a bit. Does 14 go into 70?
Yeah.
Yes.
5 times.
5 even? So we'll put our 5, we'll multiply, we'll get 20. We get 7. We subtract, we get 0. Sorry, I know that's squished down there. So our final answer is what?
Negative 1.15.
That's it, negative 1.135. Would you raise your hand, feel okay with that one?
How did you get minus 42?
Well,
49 minus 42.
every time you do one of these numbers, you have to multiply. So 14 times 3 is 42. Okay, let's try one more together. Hey, by the way, what number's going on the inside of our division symbol?
Negative 2.
Do I need to put the negative?
Yes.
No.
Let me ask you a question.
Yes.
Is our quotient going to be positive or negative?
Positive.
So as soon as you calculate that sign initially, you don't have to put those negatives anymore. I know for a fact that my answer is going to be positive. You with me?
Yeah.
So ignore those negatives. You've already done that part. You're going to do 2.808, and you're going to do 104. Okay, folks, stick with me. First thing we're going to do is what?
Mind the decimal.
Okay, we got to do that. So before we even get to work, I want to make sure that my decimal is there. Next thing we do is our division if we can. Now, of course, 104 doesn't go into 2. It doesn't go to 28, but it does go into 280. How many times do you think?
Twice.
Yeah, probably just twice. But, oh, wait. Whoa, hang on.
You put 2 zeros.
If I do this right here,
0.
if it doesn't go in there, it doesn't go in there, it goes in here, can I do that?
Yeah. No, you
No.
don't
No,
put
you
0
have to
there.
put 0.
This is where people make kind of a big mistake. When they're going through this, if you can't divide a number, technically you're supposed to put a 0 there. Now normally when you're dealing with whole numbers, it really doesn't matter if the 0 is right here. But as soon as you start going past a decimal, yes, it matters if you're going to put a 0 between some other number and a decimal. It moves that place value over. So in our case, here's how you'd write this. You'd say, does 104 go into 2? No. Does 104 go into 28?
No.
You have to put a 0 there. It's like a place value holder. You're not going to get 0.2, you're going to get 0.02. Is there a difference between 0.2 and 0.02?
Yes.
Huh?
Look at your bill.
Do you remember the rest of the bill? You remember? Ha 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 ha. That's pretty good. I worked that in there somehow. Now you get $0.002. There's no such thing as $0.002. Ah, it's the best. Okay, yeah, it goes into 0.02, not 0.2, but 0.02. There's a big difference there. You have to have that zero. Nod your head if you see why you have to have that zero. Shake your head if you don't. Yes, no. Yes, okay. Continue to multiply. We're going to get 208. 72.
Bring down the 8.
We do bring down the 8, and we check 104 into 72. I'm guessing it probably goes in 7 times.
Yeah.
So I'm guessing, because I'm estimating with 100. Go 1, 2, 3, 4, 5, 6, 700, probably 7 times. When we multiply, you get 728. We subtract, we get 0. Do I need to add a 0 on the end of this number?
Nope.
No.
No, so this is it. Do we have a positive or a negative?
Positive.
Because we've already calculated that sign, 0.027, not 0.27, 0.027. That's 10 times different right there. Would you raise your hand feel okay so far? All right. Let's continue to move on a little bit.
Mr. Leonard,
Yeah.
so like, the negative sign you put it on the bottom.
Where at?
Or is it 2.8, or you didn't bring the negative with it?
Well, because I know this is division, right? And I know I'm dividing a negative by a negative. I know a negative divided by negative is a positive, right? So we can do the sign like in our head first and omit the signs from here so we don't need to write them. As long as you calculate that, like on this one, we knew this was going to be a negative, right? So I wrote that negative first and then I didn't write them down here at all. Because I knew that was going to be a negative before I even started. I know this one's going to be a positive before I even start. So we're identifying the sign first, then we're doing the math on it. Does that work? Let's try one more together. I'll show you why it works, and then we'll continue. Let's do 29.585 divided by 4.85. Let's set this up the same way we did these other problems. So the first thing we'll do is make a division problem like this. Can you tell me what number is going to go on the inside?
29.8.
And 4.85. Now, stop and look for a second. Normally what you'd be doing on every other example, you'd be putting this decimal place right up there, right?
Yeah.
However, does this one look different than the first 4 or 5 examples we did?
Yes.
How is it different?
Because there's 2 decimals.
Yeah, here we didn't divide by a decimal. Here we didn't divide by a decimal, or here, or even here. But here now, or here, now we are divided by decimal. This isn't going to work the same way that these ones did. We have to somehow translate this to look like these ones. Fortunately for us, there's a very simple way we can do it, as long as you remember that you can do this. What we're going to do is we're going to move this decimal place to make it look like these ones. We're going to move it over until it becomes a whole number. You're going to count the number of spaces that you need to move. How many spaces do I need to move here? 2. So to make that a whole number, I had to move 2 spaces. Now, we do the same thing with the number under our division symbol. How many spaces again?
2.
Wait, why did you move it 2 times?
You have to make this a whole number. It won't work if that's a decimal. So right now, we're translating this 4.85 into 485. But what that means is that if you move these 2 spaces, you also have to move these 2 spaces. It's necessary. You can't move one without moving the other. Nod your head if you're okay on that.
Yeah.
So this, instead of being 4.85, it's 485. Decimal's gone. It's a whole number now. Instead of being 29.58, it's 2,058.5. So we've moved the decimal place 2 spots on both the numbers. Raise your hand if you're okay with that. It's a big deal. Good, okay. Well, now we got something we can work with. Now we have the same looking type of problem. What are we going to do after this, at this point?
Put the decimal on top.
Now we can, because we have a whole number over here. Now we can put that decimal where it's supposed to go. And then we would do our division as normal. By the way, do you want to see why this works? Why you can move that?
Yeah.
Okay, here's why. Because maybe, have you ever seen that before, by the way?
Yeah.
Some teacher somewhere might have taught you how to do that. Here's the reason mathematically why you can do that. Notice that 29.585 divided by 4.85 can also be represented as a fraction. 29.585 divided by 4.85. Do you see it? That still means division. Here's what you can do with a fraction. You can multiply both the numerator and denominator by the same number. What I'm going to do is multiply it by 100. The reason why I multiply it by 100 is because I know if I multiply by 100, all that's going to do is move that decimal place over 2 spots. Are you with me on that?
Yeah.
Moving that decimal place over 2 spots if you multiply by 100. I have to do it to the top, however, as well. That's the whole point here. If you're going to move this decimal place, i.e. you multiply by 100, you also have to do that to the numerator. That's why you can't just move one number without moving the other number. You got to do both because it actually is a fraction, and what you do to the numerator, you do to the denominator. So this makes it, sure, it makes it 485, but this makes it 2,958.5. Multiplying by 100 moves that decimal place just like it did that one. That's the reason why this whole thing works. Did you follow that? Okay. Good. Are you guys awake today?
No.
You better wake it up. You better wake it up. We got a test coming up on Monday. You know that, right?
Yes.
Then we do our division as normal. So let's go ahead and try to do that together. 458 into 29? No. Into 295? No. Into 2,958? Yeah. How many times?
6.
I'm going to guess 6, yeah. The reason why I do that is I think that's about 500. I'd say 500,000, 1,500, 2,000, 2,500. 3,000's a little bit over, but this number's smaller than 500. So I'm going to choose 6. Hey, if I'm wrong, I just redo that one lower. So let's try 6. I'll get 30. I'll get 48, 49, 50, 51. I'll get 24,
Yes.
29. Hey, that worked out pretty good. So I have a 4 and an 8, and then I'll bring down the 5. How many times does that go in? Well, that's kind of nice.
Really?
I picked a good number for you guys. Subtract, we get 0, so our answer is 6.1. How many people feel okay with this so far? If you're not raising your hand, I'm going to assume that you don't really kind of get it. Yes, no? Yes, good, all right, fantastic. We're going to try 2 more together. I'll give you 2 to do on your own. We'll talk about a couple of other situations that can occur when you're dividing these decimals. Then we'll move on on how to change a fraction into a decimal. So let's try 10.764 divided by 2.3. Then we'll try this one. Notice how I'm putting parentheses around there signifying that we're not subtracting, we have a negative number. So first one set up for you. Y'all tell me, let's work together on this thing. What's the first thing you're going to do on this first problem over here?
Move the decimal over.
How many spots?
1.
So moving the decimal, we translate this problem into a whole number, and that's what we really want to do. So instead of 2.3, we now have 23. Instead of 10.7, we have 107.64. After that, we got to make sure that decimal place is also up here in the quotient. And then we're going to divide. Let's go ahead and divide together. 23 doesn't go into 1, doesn't go into 10. It goes into 107 how many times?
4.
Okay, that's a 12 with a 1 and a 9. How much is that?
15.
We'll bring down the 6. I'll erase that number that I carried over. How many times is 23 going to 56? 6 times? Maybe you're estimating with 25. You can do that. Estimate with these numbers to find these out. So 25, 50, 75, 100, 125, 1. Yeah, this is probably about 6 times. We'll get 18. We'll get 13. How much is that when we subtract?
I think you can go in by 5.
What now?
Six.
No.
It equals 18.
18?
Bring down the 4 and go in the
Bring down the 4. Okay, we could do that. And how many times is 23 going to go into 184 without going over?
8 times.
8 times? If we subtract, we get 0, so our answer is 4.68. 4.68. Let's do one more. First thing, this problem, is our answer going to be positive or negative?
Negative.
Definitely negative. So we can omit that negative when we're working on our problem. We'll just have to set this thing up correctly. Make sure we have our 5.264. Make sure we have our 0.32. And do one more thing for me. Before you do anything else, put your negative there. Don't forget about that negative. Your answer is going to be negative. Don't forget about it. That'd be a horrible way to lose like 3 problems on your test. You want to make sure you have that down at first. At least you know the sign of it. Okay, next thing up. What now?
Move the decimal over.
Ladies and gentlemen, how many places are we going to move that decimal to?
2.
So that's 1, 2 here, and 2 there. I'll erase these. I don't really need that 0 anymore, since we're talking about a whole number now. So you should have 32 going into 526.4, and I'll make sure my decimal is also on the top of my division problem. Okay, 32 does not go into 5, but it does go into 52 one time. So we'll make that 32. We'll subtract, and we'll get
20.
We'll bring down the 6 and get 206. 32 into 206. Oh, how much is that?
4 times.
6 times?
4.
Looks like we're going to get 14. If I bring down that 4 again, we get 144. How many times does 32 go into 144?
4 times.
4?
Yeah.
Okay.
28.
So 4 times 2 gives us 8. 4 times 3 gives us 12. If I subtract, how much am I going to get?
16.
Wait a minute, am I done?
No.
Add a 0.
A 0. Okay, I can still do that.
And the 32 times 5 is 160.
5 times?
Yeah.
So we'll put that 5 up there. Yep, we're going to get our 10. We'll get our 16 out of that. When I subtract, I get 0. So sure enough, we get our answer of, what is it?
Negative.
Negative.
Good, I like the negative. Make sure you got that negative there. Negative 16.45. Try 2 on your own, and then move on. All right, so let's continue. We've got some division going on. Hopefully set this thing up appropriately. We've got our 166.88. We got our 5.6. And the first thing you got to do, make sure we have a whole number because we can't really divide by a decimal. We're using the fact that we can multiply by the same number on both the numerator and denominator of fraction to change where that decimal place actually is. In this case, we'd be multiplying by 10, or in other words, moving this decimal place over just one spot. on both those numbers. When we divide, we check 56 into 1, no, 116, or sorry, 16, no, 166.
Yeah.
Probably how many times?
5.
156 into,
2.
3.
is it 2 or
No,
3?
it's
two.
2
Two.
times.
Okay, so 2 times we'll get to 12. We'll get,
1, 11.
and if we subtract, we're going to get 54. If the number's less than this number, you know you did it right. If it's more, then you need to raise that up a little bit. And we'll bring down the 8. I'm going to guess, oh, how many times?
9.
9 times?
Mhm.
Okay.
Or 8.
What do you think?
9.
8 or 9.
I'm going to guess 9. If I did 10, it'd be 560. That would be too much. So I'm going to do 9. That's going to be less than 560. This probably should work for us. That'll be 54. 45 plus 5 is 50. And if I subtract, I'm going to get 44. I'll bring down that 8.
8, it goes into 8.
Yeah, it's going to go in 8 times. I would check with probably 50. It's going to go in 8 times. That's our 48 there. We're going to get 40 plus 4 is 44. Subtracting, we get 0. Our answer is 29.8. Raise your hand if you got 29.8. That's good. That's really good. If not, well, where'd your math come in wrong? Was it calculating these numbers up here, or was it doing some sort of multiplication or subtraction error? Just watch that for next time. That way you can eliminate that error. Okay, next up. Is our answer be positive or negative? What do you think?
Negative.
Negative.
Definitely negative. We got a negative divided by a positive. So I know instead of writing my problem with all these negatives, all I've got to do is make sure I have one negative up there. I know my quotient is going to be negative. Also, I'm going to have 0.16 and 1.976. How many places do I move that decimal to?
Twice.
Good deal. All right. So 16 and 197.6. I'll make sure that decimal place goes on the top of my quotient. 16 goes into 1. No, it doesn't. 16 goes into 19. Yes, it does. How many times?
Once.
So of 16, we'll subtract, we'll get 3, bring down our 7. I'm guessing that goes in twice because that's 32. If I subtract and I bring down my 6, 16 into 56, how much is that?
3.
3 times?
48.
Well, it looks like we're going to have a remainder. If that happens,
Add a 0.
that's what I got to do. So I'm going to bring down a 0 here. 16 into 80?
5.
It should be 5 times.
So it goes into
So negative 12.35. Folks, do you have a good feeling about how to do these division problems? Yeah or no?
Yes.
All right, that's awesome. Very, very good. So right now we know that if we're dividing these decimals, really a couple key things happen. First thing, we got to be dividing by a whole number. So we're moving decimal places over to make our number we're dividing by, divided, into a whole number, and that subsequently moves each of these decimal places the same amount over. Also, we know that our multiplication rule for signs, our division rule for signs still works. So we're calculating the sign of our quotient before we even do the work. That way we don't have these negatives floating around everywhere. Third thing we know is we can always add a 0 at the end of our number to continue the process. That way we can find out, instead of having a remainder, what the decimal equivalent is going to be. Let's try one more. One more here. So first thing we're going to do, of course, we're going to make this. What number goes on the inside?
0.7.
On the inside.
0.6.
I'm going to put 0.86. That way, don't let that 0 confuse me. On the outside of my division problem, I have 0.7 or just 0.7. And how many places do I need to move the decimal? 1 or 2?
1.
1.
So I'm not really looking in here. I'm looking out here, and that's dictating how many spaces I move. So 1 space over means 1 space over. And of course, I put my decimal on the top of my quotient. Are you guys ready?
Yeah.
Okay, let's check this out. How many times does 7 go into 8?
1.
Once.
So I know it's a 1. I multiply, I subtract, I get 1. I bring down the 6. Okay, how many times does 7 go into 16?
2.
2 times.
I'd get 14. I'd subtract, I'd get 2. True?
Yes.
True.
I add a 0 on, I bring it down, I get 20. How many times does 7 go into 20?
2.
2.
Okay, that's 14. I subtract, I get...
6.
How many times does 7 go into that?
8.
Okay, subtract, how much am I going to get there?
4.
That's a lot of work. Some of these decimals, they don't end right away, do they? So a lot of times, yeah, it's going to go on for a long time. Okay. A really long time. In fact, I don't even know if this one ever ends.
I just go.
You did? Oh, you should have waited for me. That's why we do them together. So a lot of times, here's what's going to happen. A lot of times your question will say this, but then at the very end of it, it'll say, and round to the nearest blank. Don't ignore that, because if you do, you might be going forever. Okay, this number repeats, but I'm pretty sure it doesn't end. It just repeats somewhere. All right, so you don't want to do that for eternity, do you? That'd suck. If you're doing math for the rest of your, well, you'll be doing that anyway. But but that would suck to work on this one problem, right? You don't want to do that. So a lot of times I'll say, do this and round to the nearest. Don't ignore that. Round to the nearest, let's say 10, 100. In this case, 100. It might be the 10th. It might be the 1000th. In this case, I want to round to the 100th. You ready?
Yeah.
Can you locate where the 100th is in my problem up here?
The second.
This one?
Yes.
Okay. This is the one I'm looking. Do I need to go any further then? So as soon as you make it one past the decimal place where you're supposed to round, stop. So if I had said to the 10th, we'd have gone too far. We'd have gone one too far. We wouldn't even need this 8. If I would have said 1000th, we'd need one more to be able to round that. Are you with me?
Yeah.
So here, if I'm supposed to round to the 100th, I know I'm going to have 1.2 what? We look at our 100, that's right here. That 8 says you round that up one spot, so we have 1.23. That's rounded to the 100th. We know how to round. We know what the 100th is from our place value work. Now we can go one more little place value, and that's going to allow us to round to the appropriate one that the question's asking for. Does that work for you? Okay. Okay, here's what I'd like for you. I want you to do one on your own. Let's have you round this number to the nearest. Let's go 1000th again. That one works pretty well. So divide and round to the 1000th. So of course we're setting this thing up, we're moving that decimal place, dividing, and then round to the 1000th. Okay, so 8.6 outside of 519.37. Number of decimal places we're moving is
One.
One.
good. So 86, and we change it to 5,193.7, and of course we'll put the decimal place right up there. Oh my gosh, to the thousandth. We got a lot of work to do. So we'll start with 86. 86 into 5? No. 51? No. 519. How many times into 519? 6 times? 6 times? So that's 51. We subtract, we get, oh, how much?
3.
3, but we bring down the 3.
Gotta put a 0.
I want your eyes on the board here real quick. You guys are okay on the 3?
Yeah.
You okay on getting that 3?
Yeah.
Does 86 go into 3?
No.
That's why I brought one down. Does it go into 33?
No.
No.
Okay. What would you do now?
Put a 0 on top
Ah.
of
So you would bring down a number, but not before putting a 0 on the top of your problem. Because on the test, I'm going to give you something like this, just like this on a test. Some people are going to give me 6 point, and some people are going to give me 60 point. What's the correct answer? It's 60. If you, here's the key. If you bring down a number, you have to put a number up top. Even if it's 0, you have to put something up there. So here was 3, we brought down a 3, now you have to put something up there. To bring down another one, you have to put something up there. That's right. And now we need to bring down another one, and we check 86 into 337.
3 times.
Evenly?
3.
No.
No. 258.
Subtract it, you get 79,
79. Okay,
Bring down the 0.
Ooh, all right.
and then it goes in
9 times.
9.
774.
774, and then subtract.
You guys are good. You sound like robots.
16.
You get 16,
Okay.
bring down 0,
Oh.
Keep going.
Oh my gosh.
you go twice.
Keep going.
Wait, twice?
One. One time.
One time.
Oh,
My robot stopped. My robot. Okay, 86. Yeah, 86 because you're going to get 74, right?
Yes.
Now, hang on a second.
You can stop.
We can stop here?
Yeah.
We need the 1,000. We need to go one more than that. 86 into 740.
8 times.
8 times? Let's see, 64, 68. Oh my, okay, 6, 13, 52.
We can stop there.
We can stop there though. Yeah, but it's not going to end for a while. Well, maybe, I don't know. But it doesn't really matter. We just wanted to go to the 1,000th. If we've made it one past the 1,000th, we're okay. Are we going to leave the 1 alone or raise the 1 up?
Raise it up.
That's our 1,000th place value. We look right here, we'll have 60.392. Done. Raise your hand if you feel okay with this so far. Now, very quickly, I want to show you a couple things that we can do. Then we'll do 2 more examples, and we'll be done with our day today. First thing that we can do, if you're ever dividing by a multiple of 10, so like 10, a multiple of 10 starting with a 1, like 10, 100, 1,000, 10,000. All you need to do with this, if you do the division, you can't do it that way, like our long division. However, what this is essentially going to do is simply move that decimal place. Just like multiplying by 100 does, or multiplying by 1,000 does. It just moves a decimal place without changing the value of each digit. So in our case right here, if we're dividing by 10,000, what this does is moves the decimal place to the left, however many zeros you have. How many zeros do I have?
4.
4 zeros. It's going to take this number and make it smaller by a factor of 10,000. That means I'm going to take this decimal place and move it 4 places. Wait, which way? Dividing makes...
Right.
If I move it right, that's making the number bigger.
Go left.
I'm dividing this number into 10,000 little parts. Is that going to make it smaller or bigger?
Smaller.
Well, smaller. Dividing...
Left to the left.
0.049368.
Why would you do it like that?
It's a lot quicker than doing this.
No, but I was thinking you probably move to the right, no?
If you multiply, yeah,
Oh, so it's different for division?
yeah, it's opposite. Opposite for division. If you did this one, I mean, you could see that you're gonna have the decimal there, right? 10,000, no, 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 yes, goes in 4 times. So 0,
I don't get how you move that to the left, but then you move it to
Because it's
the right.
opposite.
Because the numbers are on the opposite.
Oh.
those are different problems. Multiplying by 10,000, you're making that number bigger. You're moving it by a factor of 10,000 to the right. Dividing, you're moving to the left. You're making that number smaller by a factor of 10,000. So, if you don't remember that on your test, no big deal. Can you still do it this way? Of course. You just add a whole bunch of zeros and work out exactly the same way. Yeah.
So that would be our answer right there, 0.049.
This is it.
So all you have to do is cross the zeros.
Move them the appropriate number of zeros. That's what we're doing. Okay, last thing I need to show you here, folks. When you're faced with a problem like this, will you be able to do it for evaluation?
Yes.
Do you know what goes where?
Yes.
Yeah.
Okay, what's going to go on the top of our fraction, please?
Negative 96.8.
Over?
0.8.
0.8.
Okay, now wait a second. Can I do that?
Yes.
Yeah.
Yes.
You can set this up as a division problem. You just need to know what goes on the inside and what goes on the outside. What's inside?
So you
That's 96.8.
Whatever the top one is. Also, is our answer going to be positive or negative?
Negative.
So we'll make sure that's negative. 76.8.
have to move to the left.
And then you do it according to that. I won't finish the problem off for you. I just want to make sure that you see that. How many people feel okay with what we talked about so far? So you can also do one more thing. You can check for solutions, but it's very similar to doing our evaluation right here. So at this point, you should be able to divide any decimals I give you. If it ends, you can add zeros. I'm sorry, you can add zeros to the end of your decimal until you get the lack of a remainder, or read the problem, and if it has you round, go to one more decimal place than you need, and then round appropriately. How many people feel pretty good about what we talked about? Good deal.